When we're working with linear equations here, the goal is to isolate the variable by itself on one side of the equation, and then make sure that you have one unit of that variable. In order to do that, we're going to have to undo whatever's going on in the problem in order to make sure we've got everything with letters to one side, numbers to the other side, and then take what's in front of the number or what's in front of the letters and undo it with either division or multiplication. So we're going to start with addition and subtraction. I'm going to look at the letters here. I'm going to say, well, 9 is bigger than 4, so I'm going to take my letters over here. That means right now, 9's with a V, it's with a letter, so it's in the right place where I want it. This negative 5 is in the wrong place. If I want to move it to the other side of the equation, I have to undo it. Since it's a negative 5, a positive 5 is equal and opposite, and we'll undo that negative 5. Similarly, on this side of the equation, we want to get rid of the letters and move them over here. So, this 4V, to get rid of that, I'm going to have to put negative 4V. In each case, what I do to one side of the equation, I have to do to the other. So since I did plus 5 to the left here, I have to do plus 5 to the right. Since I did minus 4V to the right, I have to do minus 4V to the left. These will go away, which means I just have to combine 9V and negative 4V to get 5V, and 10 plus 5 to get 15. The last step is to say, well, if this is now 5V, that really means 5 times V. To undo multiplication, we're going to do division. So I'm going to divide by 5 here, divide by 5 here, and that gets me to my final answer that V equals 3. In number 2, the larger variable is on the right side. So in this case, I'm going to take letters to the right, numbers to the left. So this 1 has to move, this 2W has to move. When I resolve it, these go away. 7 minus 1 gives me 6. 4W minus 2W gives me 2W. This is really 2 times W, so to get W alone, we'll divide it by that 2. That's how I get my final answer of W equals 3. We could have gotten to the same place by taking letters to the left and numbers to the right. It all would have worked out the same. It would have been the exact same answer, W equals 3. The only difference is we'd have to deal with negatives. It would have become negative 2W equals negative 6. So in general, I like to move the letters to the side where there's the largest letter, but it absolutely would work if you just always like to move the letters to the left. You just might have a tricky negative that you have to deal with. In problem number 3, we actually already have things on the right side of the equation. We just need to combine like terms. 2x's and 6x's give me a total of 8x's. Negative 10 minus 14 gives me a total of negative 24. Really, when you see two negative numbers like this, you add them and keep the negative sign. When I now have 8 times x on the left, to undo that times, I'm going to divide by 8. That's how I get my final answer, x equals negative 3. In problem 4, again, we have the like terms on either side of the equation. So we start with the x's. 5 minus 6 leaves me with negative an understood 1x. Negative 15 minus 18 leaves me with negative 33. Now we do have x alone, but that negative sign, again, really stands for a negative 1. Just like we had to treat the 8 above by dividing by that 8, here we have to divide by negative 1. When you divide or multiply by negative 1, all you're really doing is changing the sign. So what was negative becomes positive x. What was negative 33 becomes positive 33. In problem number 5, I only have one thing to move, but it's a fraction. I know we don't love fractions. That said, if I get rid of 2/5 on the left here, these will go away and just leave me with this x. If I take 3/5 minus 2/5, then the way I combine fractions is I keep the same bottom, do top minus top, 3 minus 2 leaves me with 1, still over that same denominator of 5. Same idea here in problem number 6. I'm going to need to get rid of this minus 1/8. To do that, I'm going to add 1/8 to both sides. This will go away. When I do 3/8 plus 1/8, 3 plus 1 gives me a total of 4/8. The difference here is, even though I have x by itself, my fraction is not in its lowest possible form. Back when we had 1/5, there was no number that could go into both 1 and 5 to reduce them. In this case, 4 and 8 do have two different common factors. I could divide them both by 2 and get to 2/4, but really I would want to divide by 2 again to get to 1/2. The better way to see it is this is like saying 4 times 1 over 4 times 2. We get rid of that factor of 4 and we're left with 1/2. Final answer should be x equals 1/2. In problem 7, we have 3 times y equals 1/3. Little tricky here. Your mind wants to say, well, I'll just multiply both sides by 3 and y will equal 1. But that's not what's going on here. Because if I multiplied by 3, I wouldn't get just y. I'd get 9y. In this case, 3 times y is what we want to do. So we want to really divide by 3. That's easy enough on the left side to just get y. But what does it mean when we divide a fraction by 3? Well, really, when you divide a fraction by a number, you want to think of it as multiplying by its reciprocal. So dividing by 3 really means what we're going to do is take the 1/3 that was already there and multiply by 3 over 1 flipped. So it becomes 1/3 times 1/3. 1 times 1 gives me 1. 3 times 3 gives me 9. That's why my final answer should be y equals 1/9. In problem 8, same general idea. We're trying to say, how do we undo what's in front of the x? In this case, if it's right now 1/4 of x, if we multiply by 4, that'll undo the 1/4. Or another way to look at it is, I can multiply by the reciprocal. This was 1 over 4, so to undo it, I would multiply by 4 over 1. What I do to the left side, I have to do to the right side. Over here, it's just going to leave me with x. On this side, -2 times 4 gives me -8. 15 times 1 gives me 15. I always want to check whether something goes into both -8 and 15. There is no common number here, so I can just leave it as -8/15. Again, when I see a problem like this, I'm going to multiply by the reciprocal. In this case, since it's negative, I'm going to multiply by a negative. That way, my answer will be positive. It's right now 7 over 8. I'm going to do it by -8 over 7. What I do to one side, I have to do to the other. Here, these will go away and just leave me with x. Here, a negative times a negative gives me a positive. There's 2 different ways I can look at this. Either I can say 8 times 1 over 7 times 8, which would give me 8 over 56. I'd have to then say, can something go into both? There would be something that went into both. 8 that I could reduce by. Or I could at this step see, well, wait, there's an 8 on the bottom here, an 8 on the top here. Why don't I just cancel those? Now it's going to become -1 times -1 equals +1, and 1 times 7 equals 7. Again, if I did it the multiply out way, I would get 8 over 56. 8 goes into both of them, and it would reduce to the same 1/7. Final problem here. I have to get rid of the 3/4 by adding 3/4. But when I do it this time, I don't have a common denominator. So instead of just adding the fractions on the right, I'm going to need to create that common denominator. When I look at 8 and 4, the least common multiple between them would be 8. The way that I get to it is multiplying by 2 over 2. That leaves this as 1/8. Instead of adding 3/4, we're now adding 2 times 3 is 6, over 2 times 4 is 8. Since they have the same bottom, we now can combine them and leave them over that same bottom. 1 plus 6 gives me 7/8. So again, we couldn't combine these two. The way I found this 2 over 2 was really by applying the least common multiple. If I look at the multiples of 4, 8, 12, 16, 20. The multiples of 8, 16, 24, 32, 40. This is the first number that appears on both lists. That's really how I knew that both of these denominators would have to be 8 in order for them to be combined.